Hey guys, in this video we are going to discuss the problem smallest missing non-negative integer after operations. So the problem states that you are given a zero integer array nums and an integer value. In one operation you can add or subtract values from the element of nums. For example, if this is the nums and your value is 2, and if you subtract 2 from 1 you get -1. That's obvious, right? And then we have to print the or we have to return the max or the minimum excluded of an array, right? And what it is, so it's basically the minimum non-negative integer that is not present in that array. So you have to try to maximize it then, right? After performing these kind of operations, so either you subtract it or you add it, or you subtract or add vals as many times as you want. After that you'll be getting an array. For example, over here, like your max is 0, right? Over here your max is 2. So you can perform these operations any number of times as you want, and then you have to return what is the max in your array, and you want to maximize that using these operations. So how would we do this? Now let's talk about simple observations which we can utilize over here. So very simple thing is that you want to maximize your mix, right? And your mix starts from 0, 1, 2, 3. So it obviously makes sense for you to have a 0 in your array, right? Then it would make sense to have a 1. It won't make to sense. It won't make sense to have a integer I plus 1 if you don't even have a I, right? But the problem over here is that you can add just value to your number, right? So you can have a number x and then you can add a value to it in n times, right? Or any number of times as you want. So let's call it y. So this is what you can do, or you can subtract the values any number of times as you want. Okay, subtracting over here. So how does this helps us? So what we'll say is that let's group the numbers based on their modulus with 0. Now why I'm doing that? Let me explain that in a while. So let's say I have the numbers 3, 6, 7, then I have a 9, right? And then let's say I have a 8. Okay, let's say 8. I already sorted it so that it's easier to explain. Now let's say my value is 3, right? Now what would happen is I can say that I'm going to subtract 3 from 3, I'm going to get a 0, right? If I subtract 3 from this, I'll get a 3. If I subtract 3 from this, I'll get what? Okay, yeah, I'll get 4. If I subtract 3, I'll get a 5. If I subtract 3, I'll get a 6. Cool. Now 0 I already have, right? What's the next number I require? The next number I require is 1. So I can subtract 3 from this. I'll still get 1. So this is 0, this is 1. What's the next number I require to maximize my mix? That's 2. So for 2, I can say I subtract 3 from this, right? I'll get 2. Now I can say I'll subtract 3 from this. I'll get 3. Now can I get a 4? Obviously I could have got a 4 if I used that, but I already used this. Now how do I keep a track of all these things? Now if you take if you take a step back and you try to notice, so what's happening over here is that whatever your number is, right? So for example, if I just took a mod of these numbers itself, so your mod 3 gives you 0, mod 3 gives you 0, mod 3 would give you 1, right? Mod 3 would give you 2, and mod 3 is going to give you 0 for here, right? So these are the numbers that you can make. So for 0 I can say I can make either 0, 3, 6, 9 up to so on, right? For 1 I can say I can make 1, 4, 7, or I can make 10, then 13, then 16, right? On so on. For 2 I can make 2, 5, okay, 2, 5, then 8, then okay, you have 9, then you got 11, then 14, so on. So these are the type of numbers that you can make, right? Because all of these numbers have mod 0, so you can make it with mod 0. All of these numbers have mod 1. All of these numbers have mod 2, right? This is something definitely you can do. Now you just store them in a set. So let's say I'll take a map or a hash map or whatever you want, whatever data structure you want, you store these into that. So you'll say that your MP of vector I mod value that was provided to you plus plus for all the elements in I to n, right? And then you'll start traversing from I is equal to 0 to n minus 1. What would happen is that at every step you'll be able to tell your program that is it possible for me to make an element equal to 0, right? So that would only be possible if you have a vector of 0 or a map of 0, right, greater than 0. If you have this, then you can take an element out of this map, right, and utilize this for 0. So you will say if it's so, then mp minus, or sorry, mp of not minus minus, right? And then continue. Then you'll check for 1, right? So you'll say if my mp of 1 is greater than 0. If that's the case, well enough, good enough, I'll subtract this, right? Then you'll check for 2. mp of 2 is greater than 0. If that's the case, good enough. If not, so let's say at a certain index I, or at a certain number I, you notice that it's not possible for you to go forward with that. So you'll just return the number I itself, because it's not possible for you to generate a number I. So it could have been the case that, for example, over here you already had a 7, right? So you had stored mp of 1 equal to 1. But when you checked for 0, so this got consumed. When you checked for 1, so this already got consumed, right? So this got consumed. So when you checked for 1, your mp of 1 actually becomes 0, right? You subtracted it by 1 while checking for this. Now 2 also was fine. Your 3 also was fine. But as you came to 4, you said that I need mp of 4 modulus 3, right? Which is mp of 1. Do I have an element in this particular map? No, I don't have that element. So I'll have to return. I hope this makes sense. I'll walk you through the code also. So the code is also simple. What you need to do is you need to take a hash map, and then you need to these computation. Now what's this actually? So over here the numbers can also be negative. So in order to make this, so we don't want to have negative moduluses, right, or negative numbers in a hash map. Now in order to make them positive, I'm adding a v over them, right? And v actually is the value I had. So I'll take nums modulus v plus v modulus v, right? So that's exactly doing the same thing. The only difference is if it's a negative value, it'll make sure that it becomes a positive value before being added, right? I'll increment its count. Then I'll go from 0 to n. I can go from 0 to n or equal to n here. Okay, so if that happens, or if my map contains an element with the value I modulus v, then I'll subtract it. If I don't contain that, then I already got my answer. I cannot move ahead, right? And all of this, if it happens, then just return any dummy value, because it's always gonna return, or it's always gonna like this case always gonna hold true. But still you need to mention something over here, so just mention n. Cool. So this was the code. I hope you understood the solution. If there are any doubts, let me know in the comment section below. Thanks a lot, guys.